If you are a React or React Native developer who is interested in on-device AI, this is for you. I'm Roman, and I'm a software engineer on the AI experiences team at Meta AI. I'm excited to share with you today PyTorch Live, which brings on-device machine learning support to React Native. Like I just mentioned, I'm on an AI team, but don't let the name fool you. I have no AI background. Before joining this team, I was an academic researcher and had mostly done web development. As much as I was excited about the opportunities that AI provides, it felt intimidating and I didn't know where to begin. I wanted to explore AI, but I also wanted to use the tools that I know and love, like React and React Native. However, there is no first-class support for on-device ML models for React Native. For me to get started with on-device AI, I would have had to learn both Android and iOS and the intricacies of the platforms where it runs in order to implement on-device AI experiences. And no one has time for that. Wouldn't it be nice if there would be a React Native package that would bring first-class support for on-device ML inference to React Native? I thought so too, and that's why I'm here today. Luckily, I'm not alone. I work with a fantastic group of individuals on the PyTorch Live team who share a vision to make this happen. Our vision with PyTorch Live is to empower the community to easily discover, share, and use machine learning models. As our team is just starting out, I'll only be talking about the use of machine learning models today. However, we will also be working on making it easier for anyone to discover machine learning models, to adapt or create new AI experiences, and to easily share their creations with the community. PyTorch Live is meant to cross-pollinate machine learning researchers and mobile developers. Machine learning researchers bring on-device ML models, and mobile developers will leverage those models to build apps showing real-world examples for those models. Today, I will be talking about what PyTorch Live is, what PyTorch Live currently supports, how you can get started with it, and what you can expect from PyTorch Live in the future. Currently, PyTorch Live is a set of tools to build mobile AI-powered experiences, but it will continue to grow over time. These tools support building mobile AI-powered apps with React Native and run on both Android and iOS platforms. To achieve this, PyTorch Live is powered by PyTorch Mobile and React Native. First, React Native to build many platform visual interactive user interfaces. Second, PyTorch Mobile for fast on-device machine learning inference. There is a growing need to execute ML models on edge devices to reduce latency, preserve privacy, and enable new interactive use cases. Both projects are active and flourish in open source projects with tons of examples and tutorials. And by the way, when I said that I felt intimidated when starting with AI, this goes the other way around too. It can feel equally intimidating for AI researchers when getting started with mobile development, which is why we are bringing together two big communities to benefit from each other. Here are three highlights of PyTorch Live. First, a command line interface which quickly sets up the mobile development environment and bootstraps React Native app projects. You can also add the React Native PyTorch package to existing projects and start from there. Second, a data processing API, which prepares and integrates custom models to be used with PyTorch Live. Third, a cross-platform API to build AI-powered apps with React Native. In this talk, I will only be able to focus on the cross-platform API, but we have documentation and tutorials for all three. As an example, with PyTorch Live, you can integrate an image classification model into your app to detect your favorite video game characters. Let me walk you through how that works. All right, I initialized a new project with PyTorch Live CLI, and that's going to start with the image classification of my favorite video game characters. As a first step, PyTorch Live My Demos comes with a predefined example. We're just going to remove that for now, and we start from scratch. Also, let's remove the styles here as well. Great. As a first step for an image classification, what we need is an image from the camera, for example. So let's add the camera component with a style, so make sure that the camera spans the entire screen. And let's import the camera from the React Native PyTorch 4 package. All right, let's save. And as you can see, fast refresh works with React Native PyTorch 4 as well. So we have a camera available. Now, let's get access to the images from the camera whenever we press the onCapture button. As a first step, we're going to implement an async function that is a handle capture function. And that function gets an image from the camera. Now what's important here, this is an image from the React Native PyTorch package. And what we want to make sure is that we release all resources when we use the image. So let's call image release, so we free the memory afterwards. And then we can pass in the handle capture to the onCapture property. Great. Now let's just log the dimensions of the image to the console. And save. Great. If I press the capture button on the device, it's going to log the dimensions of the image on the screen. Now, as a next step, we want to run inference on that image. So what we can do is, PyTorch Live comes with a set of predefined models. Let's import one of those image classification models into the project. We're going to use the MobileNet V3 model, which is a popular image classification model. And then as a next step, React Native PyTorch core comes with a mobile model object that we can import from the React Native PyTorch core package. And that has an execute function that takes as the first parameter the model and as the second parameter the image. And this is an async function, so let's await the seal. And also, let's store the inference result into a variable and log that variable to the console. All right, save. And if I press the capture button again, it'll log the metrics for the inference, how long the inference took, and other metrics. And then it also logs the confidence and the max index to the console. This maximum index is mapping onto a class. So MobileNet comes with a predefined set of 1,000 classes that it's been trained on. And this is an array of 1,000 classes that it can check. So what we're going to do next is we're going to resolve that class from that index that we received from the model. But before we do that, we're going to do a type safety here. Image classification result. And we know that from the model, we're going to get a confidence value, which is a number. And we're going to get a max index, which is also a number. And then we can pass this in as a type to the execute function. And that will allow us to identify the results and the max index here. All right. As a next step, as I said, we need the classes. So we're going to import those image classes as well. And then we're going to resolve the class name from that max index. And then we're going to store that in top class and lock that to the console. All right, let's try capturing a mouse. Great. As you can see, it locks computer mouse to the console. This is not very sensible for a user. So what we're going to do is we're going to render this on screen. And in order to do that, we can use the traditional React hooks. So we're going to have a hook for a top class. That is taking a string. We will be initially empty. And then instead of rendering it to the console, we can set the top class that we received from the model. And as a next step, we're also going to render this on screen. So we have this in a fragment. And then use the text component to render that on screen. And before we save, we're also going to add a style. And that's going to be a style for the label. So let's add the styles here too. And we're going to give this style a background color of white, a font size of 20, and the padding 20 as well. Great. Now let's again try to capture my keyboard here, computer keyboard, and the mouse. But as I said, we want to recognize and identify my favorite video game characters. So if I try this with a Roomba, it's going to return as a ladybug. If I try this on Princess Peach, it's going to return as a necklace. Now, this is not very sensible here as well. So what you can do with PyTorch Live, you can fine-tune any of these image classification models on your favorite video game characters, which I did beforehand. So we can just switch out the MobileNet V3 small model with my Super Mario model. And instead of mapping the indexes to the MobileNet V3 classes, we're going to map that to the Super Mario classes. Right now, we have 5 classes in here, which is Roomba, Luigi, Mario, Princess Peach, and Yoshi. So we're going to switch that out as well to the Super Mario classes. And then save again. And let's try again with the Roomba. Cool. Let's try again with the Princess Peach. Cool. Let's try with the Yoshi. Awesome. Let's try again with the Roomba. And then let's try with the Yoshi in a park. Great. So as you can see, it's not just recognizing the predefined set of objects, but it's recognizing and identifying a set of categories. For example, it can detect Yoshi, regular Yoshi, can detect a Yoshi in a cart. And that's it for the demo. On top of the basic user interface components from React Native, PyTorch Live provides a camera component for image-based AI use cases. And this is what we just used for the video game character image classification demo. A canvas component to give you the flexibility to draw primitives, for example, drawing bounding boxes around detected objects in an image, or creating free-form drawing canvases to feed drawings into a handwritten digit classifier. And by the way, the API for the canvas that we have implemented so far matches the context-to-be API from web. And lastly, a mobile API to run ML inference. We'd love to see what you all create. If you publish your apps, tweet with the hashtag PyTorchLive, and we will retweet some of them from the PyTorch Live account. Visit the PyTorch Live website for tutorials and API documentation. Check out the PyTorch Live GitHub repository for source code to make suggestions, report issues, and contribute pull requests. And join the Discord channel to connect with the community and start discussions. This is our initial approach at making things easier for you to build mobile apps and showcase your AI apps to the community. It is also an opportunity to take this a step further by building a thriving community for mobile developers and ML researchers to share and utilize PyTorch models and engage in conversations with each other. There are also short-term technical improvements that will be coming to PyTorch Live in the future. We will be adding support for other ML domains that work with audio and video data. We will also add a JavaScript data processing API to integrate custom ML models. And this will unlock potential for use cases beyond image classification, object detection, and natural language processing. And as a byproduct of using this API, you'll gradually become an AI expert, as the API will be highly inspired by the PyTorch C++ and Python APIs. I want to end with a special thanks to everyone who has helped the PyTorch Live team reach this first milestone. We couldn't have done that without you. And an extra special thanks to our first PyTorch Live alumni, Zoe Fisher, who was an intern on our team over the summer and has contributed large parts of PyTorch Live on iOS. We hope you have a great time using PyTorch Live. Thanks for watching.